In a previous video, I showed the new plotting features of NetsBlox and also a matrix library to make it easier. Here, I'd like to show a few applications that demonstrate a little bit more advanced uses of plotting. So this one shows how to use real data with plotting. In this case, we are going to plot the number of earthquakes that happened in Oklahoma in the last 50 years, year by year. So first we create a vector of the years from 1966 to 2016, and then in this loop we'll get the number of earthquakes per year using our earthquake service that gets USGS data. So if you look at this custom block, what it does, it gets the number of earthquakes per year with a minimum magnitude, in this case, of 3. Okay? So what happens is that the earthquake service has this by region call. These 4 numbers represent the approximate coordinates, latitude and longitude for Oklahoma, and then we are getting the data starting January 1st that year until December 31st of the same year with the minimum magnitude of 3 and then maximum of 9. So what this returns is actually a message saying how many events it found, so we'll just take the number out of that sentence, and that's how we return it. The actual earthquake data is sent back by the server via events, 1 event per earthquake. In this case, we are not interested on those, we are only interested in the number of earthquakes, so we'll disregard that. We won't handle that message that we get from the server. Okay, so once we have that, once we collected this data, we'll simply plot years versus number of earthquakes with these options. These options are basically just the usual way how we set up that structure. Basically, we get the default options, and then we'll set various fields in there with these access functions. All right. So without further ado, let's run this. Okay. So here we are showing our progress, showing which year we are getting data, and it's a bit slow. I mean, it's going to our server, and then the server goes to USGS and gets the data from their database. Right, as you can see, there is not much activity, and then it starts going up, way up. So once we have all the data, we simply plot this histogram. You can see that there was not much going on for a long time, and then after fracking started, the number of earthquakes kind of skyrocketed in Oklahoma. This next example is probably the most complicated from a programming point of view. What we are trying to do is basically illustrate the normal distribution or bell curve. The key to this is this random number generator. It's a custom block. What it basically does, it uses the built-in random number generator built into Snap and NetsBlox, which basically generates a uniformly distributed set of integers, and here we use the Box-Müller transform to basically generate a normal distribution. Okay. So how we do that? I mean, we are going to compute a histogram of these random numbers. So we set up a vector, in this case, from -4 to 4 with 0.1 resolution. That's going to be our bin size. So we create that vector, and then we initialize it with zeros. And then here in this loop, we are going to get 200,000 random numbers, and this code basically figures out which bin that particular random number should fall in there, and then we use one of our custom blocks in the matrix library to set that value in that vector using the index that we computed here. And then below here, every 2000th time, we update the plot and basically show the distribution on the screen. Okay, so let's run it. Again, we switch to turbo mode because then it's going to be much faster doing all these computations. And you can see that the number of samples keep going up, and this nice bell curve gets smoother and smoother the more pseudo-random numbers we are getting. And you can see that the plotting is pretty fast, even though it's going to the server, sending all the data to the server the server runs GNU plot, it generates the plot and sends back an image, and then we simply update the costume accordingly. Alright, we are not going to wait for 200,000 of these, but you get an idea, and you can see how the bell curve gets smoother and nicer as we get more and more samples. This final demonstration for today plots a bunch of sine waves. In fact, I've already run this script because it generates 721 sine waves using different frequencies. So the frequency goes from 0 to 360 with half hertz steps, and this is basically the plotting part. We generate this image and then we save these images in a list. So we'll have, by now we have a list of 721 costumes that we will cycle through quickly. Okay. So again, what we are doing is going to plot a whole bunch of sine waves starting with frequency 0 all the way to 360. So let me start by pressing the letter S, which will basically call this sweep script that will simply go through that list, switch the costume, and then wait a fraction of a second. Okay, so you can see here how the frequency is increasing, and then we are going through all these sine waves. So let's just wait for it to finish. You can see these interesting patterns as we print higher and higher frequency sine waves. Alright, so we are done, and this is something probably surprising. Our frequency is 360, yet our plot is a single horizontal line. So what's going on? Well, if you think about it, frequency 360, which means that we should see 360 full periods. But here, as you can see, we are only using 361 points on the X scale. So what we are doing is we are plotting a single point for each of those periods, and we start at 0 and going at exactly 1 period long steps. So we are going to plot this 0 for every single period. So that's why we are seeing 360 points at 0. Okay. Now with the arrow keys I can actually go up and down on these costumes. So if I go down, now we are at 359.5. This half a hertz lower. So now we see this. This is also kind of interesting. So what's happening is that we start at 0, and at every period we just shift a little bit lower than 0, right? So we get a point just very close to the end of the period, and then step a little bit again, and that's why we see this nice half hertz sine wave. If you go down one more, then we get a full period, and so on, so forth. So that's kind of interesting. If I hit space, I can actually pick which index I want to go to. So let's go to the middle, which is frequency 180. So what this means is that from each period we are putting exactly 2 points, and that happens to be again start at 0, and then halfway through a period of a sine wave is going to be 0 again. So that's why we see this line. But if we step one up, just half a hertz, now this is also pretty interesting. So what is happening is that we are plotting almost 1 point from each half period, and of course the first half period is positive, the second half period is negative. So what we are seeing here is that we are plotting this increasing amplitude, but going positive to negative and back and forth. So that's why we are seeing this nice pattern. If we keep going up, then that's what's happening. So by the way, this is a similar phenomenon that what we can see on a video when we look at a speeding car. and sometimes the wheel of that car is seemingly not moving, not rotating at all. So what happens is that each frame of that video captures the wheel at the exact same position, samples it at that exact position, so in the video it will seem that that wheel is not rotating at all. And that's basically the same thing we are seeing here. We are catching that sine wave exactly at the zero crossing, so that's why we don't see anything.